Hey everyone, and thanks for joining today for our webinar on Introduction to Graph Databases and Neo4j. My name is Adam Herzog, and I will be your host. And presenting today, I have Ryan Boyd from our Developer Relations team here at Neo4j. This webinar is a high-level introduction to graph databases. It begins with an overview of Neo4j, including why graphs matter, and then reviews the difference between relational and graph models. Ryan will also demonstrate the power of graph databases like Neo4j to query connected data using the Cypher query language. Before I hand over the floor to Ryan, I would like to let you all know that this session is being recorded and will be sent out via email tomorrow. We will also be taking some questions throughout the webinar. If you wish the presenter to answer your question, be sure to type your questions in the Q&A section of your control panel. All right, and without further ado, Ryan, you may begin.
Hello, everyone. It's great to be here today and to talk about Neo4j. Again, my name is Ryan Boyd. I'm on the Developer Relations team here at Neo. You can see my Twitter handle here, and let's get into it. Let's talk about graph databases. So the key value proposition of graph databases is typically thought of as performance and developer ease of use when dealing with data relationships. This is, of course, true, but there's a value proposition that resonates much more strongly with me personally, and that is the idea that the whiteboard model is the physical model. The way that you design your business processes on a whiteboard, the way that you design your data on a whiteboard, even for the business person who is non-technical, is the exact same way as the engineers go about implementing that model inside of a graph database. You can convert your whiteboard model to your graph database model back and forth, and everyone is on the same page. Everyone can communicate well about what the data model is and can understand it better. This really improves the communication between the business owners as well as the IT folks and developers, and just makes everyone's lives easier to be talking about the same data model. So before I get into kind of more about graph databases, I actually wanted to dive into a quick demo. I am an engineer and I love to see code, and I know that many of you on this webinar are also engineers or technical folks. So let me show you some things that may be interesting to you from a technical perspective, and then we're going to dive back into more of the value proposition and what graph databases are all about. So the first thing I want to do is actually just show you all how easy it is to download Neo4j and get started. And I'm going to use this as a way to show you the fraud detection data set that we're going to demonstrate, and how easy it is to query for fraud detection. So I'm going to actually download the community edition here. For the most part, you probably want to consider using the enterprise edition, because the enterprise edition has a lot of the scalability and performance features of Neo4j and the dedicated support team and that sort of thing. But for my quick demo here, I'm going to be using the community edition. So the community edition is downloading here. It looks like there is 55 seconds left, and it's accelerating. So I'll be able to do that. I'm going to hop over here into a fraud detection graph gist. So we have these graph gists, which are basically community contributed, and some are contributed by Neo4j, that allow you just on the web, even without Neo4j installed, to kind of go through a graph data model, look at the data set, how it looks, and actually play around with Neo4j. But I want to show you the real product here. You guys have made it to the webinar. You've shown that you're really interested in Neo4j. So I want to show you this in the real product. And it looks like we're 7 seconds left. So I'm going to hop over here to my terminal, and I'm going to unzip the download here, and I'm going to start it up. And Neo4j is going to start, and then I'm going to pop over into my web browser. Neo4j starts on this port 7474 by default. And we can see here that Neo4j is up and running. And I do need to set a password here quickly. And now I'm up and running in Neo4j. And there's a lot of things built into Neo4j in terms of getting started. Some walkthroughs here that you can look at how to convert from a relational database. You can look at this movie graph, and you can follow along there with really easy walkthroughs built into Neo4j. But today I'm going to show you this real business case of fraud detection data. And in order to do that, I'm going to set up my sample data set here. And Neo4j has a Neo4j shell. And I'm going to set the sample data set up. All of those records were added to Neo4j. And now you can see in the Neo4j browser, I'm just going to reload here. In the Neo4j browser, we have a lot of different nodes here, node types. And these are really our objects that exist in our database. And we're going to learn more about that here soon. But I want to basically show you all the data that's in this data set. So this data set is about accounts that a credit agency might have, and you can see the blue objects here, the blue nodes actually represent the account owners. And then you can see like what other accounts they have. So they have a bank account, do they have a credit card, do they have an unsecured loan, and in particular, like what are those debts? So for instance, in this case, the person with the last name Appleseed and the first name Jane has a credit card with a debt of $2,345 and an unsecured loan of $9,045 and a particular address and a phone number. And so there's a bunch of data here, and you can see how all of this interconnects. And there's a lot to be said about the visual model of this, and there's a lot to be learned even without performing any real queries by looking at this visual model. But let's actually run some real queries on this data set. So let's say that you want to find account holders who share a single piece of contact information. So oftentimes in fraud rings, there will be cross-sharing of contact information, of identity and contact information. So things like addresses or phone numbers or social security numbers will be shared across multiple people. So in this case here, we see there's actually 3 people, Matt Smith, Jane Appleseed, and John Doe, who all share the same address. So the ring size of 3. And we can see second here is Matt Smith and Jane Appleseed share the same social security number. With entirely different names, it's unlikely that that is the same person. It's possible, of course, but it's unlikely. And then we have Jane Appleseed and John Doe sharing the same phone number. So that's a really simple query that you can do to see, detect potential fraud rings. But now let's go into some of the more advanced queries of, let's say that we want to find all of the people that are in the possible fraud ring along with the financial risk associated with them. So we want to see the total amount of outstanding debt if those people are fraudsters and just walk away from their debt. And that's very similar to the last query here, except then we're adding in that financial risk column here. So you can see the visual graph model with Neo4j. You can also see something in a more traditional table model from the graph data. And the graph is still very important here because it allows the performance of querying this related data. And we can see the total financial risk, and we can say which fraud rings do we want to concentrate on most here. And then that's all we're going to do for the fraud detection section here, but I really just wanted to show you the actual product before we dive into a little bit more about Neo4j and graph databases. So now that you've seen the actual product, let's dive into a little bit more to understand where we came from in building this product, why Neo4j is the leader in the graph database market, and some other use cases that you might be able to use Neo4j for. So I'm going to jump back into my presentation, and you can see here innovators have really built on graphs. So before Google, there were folks like AltaVista that tried to index the entire web, not thinking about the relationship between different pages, but just thinking about the raw content. Google came along and really thought about it as a graph problem. They thought about how each of the pages relate to each of the other pages and built their famous algorithm PageRank upon that. And Google now has obviously become very successful. There are other examples here. LinkedIn. LinkedIn thought about jobs not as something like Monster, where it's job listings and people listing their ability to take on jobs, but they thought about it really as the network of the connections that people have. People are much more likely to take jobs from people that they are connected with, and it builds a great opportunity both for the employers and the employees to think about this as a network, to think about this as a graph. And then, from the consumer space, Facebook is obviously quite an important example of looking at graphs and looking at connections. And you're interested in posts from your friends, but you're also probably interested in some posts from your friends of friends, people that you may have met at a party but haven't yet connected with. They're really thinking about it in terms of a graph. It's one big graph. And so we have a lot of these high-tech companies that have built on top of graphs and built very successful businesses and brands. But we're seeing this, in other types of businesses as well. Data is increasing in volume, volume that's never been seen before. And we see that data is getting even more and more connected. People are communicating as customers, as employees, as friends, as influencers. People don't just hold one role in this graph. And customers are purchasing products, services, digital content, data that has tons and tons of volume that is growing rapidly. I see the little note here that some folks may have found it difficult to see the screen. I'm sorry about that. We'll look at when we upload the video if we can zoom in a little bit more. But hopefully you can see this presentation well. So data is increasing in volume a lot, especially with the advent of Internet of Things. People are putting more and more data into computers and into storage devices, and they need ways to query that data and query that data fast. Because that data is connected, the fastest way to query a lot of it is through a graph database, and Neo4j, being the world's leading graph database, is a great solution for that. So Neo4j has been adopted across a huge number of different verticals. This isn't something that is just kind of in the consumer web space nowadays. Graph databases have expanded to other innovators in spaces like financial services, doing things like the fraud detection that we talked about, in the communications world to look at the networks of systems and devices and making sure we have the most optimal routing and failover scenarios, health and life sciences, HR and recruiting, media and publishing to do things like take a content management system and bring that content management system to users and to customers as having the most relevant data for them. A graph model is very helpful for doing that. And then, of course, the social web, as well as industries doing logistics and things like routing of packages and routing of transportation mechanisms and that sort of thing. So lot of different industries that are using graph databases, and they're using it for some main use cases that we're finding. Real-time recommendations of data So like I said, with content management systems, showing the right information to people at the right time, or with retail, the same sort of thing, making sure that the products that appear first in search or as recommended products are the things that are most valuable for that customer. Fraud detection, we just saw the power of fraud detection, especially when it's visualized. And you can also perform lots of queries to have back-end processes in real time detecting fraud and taking action upon it. Master data management, you think about organizations, and even something simple as an org chart. Most people store their org chart in things like LDAP databases or Active Directory. And for those of you that are familiar with those, you have an OU tree-like structure where every person sits at one part in the organization. I previously worked for a university, and one of the big challenges we had is that people did not sit in a single place in an organization. A single user may be a staff member, may be and may be a student. And perhaps even, some people are associate professors in addition to being staff members and students. So people hold multiple roles. It's really a graph, not a tree. And so using something like a graph database makes it a lot easier to keep track of this information. So we find a lot of people doing it for organizational charts, as well as other types of master data in their systems. Network and IT operations, the failover scenario that I mentioned, as well as routing, understanding all the devices that exist out there and what the dependencies of those devices are. So if there's something that's going to happen in terms of maintenance, being able to know in advance what devices are going to be affected and taking action upon that. Identity and access management, similar to the master data management and the LDAP and Active Directory scenario I talked about. There's also multiple cascading set of roles that need to be applied, and authentication and authorization based off of those roles is really important, and so we find people using a graph database for that. And then, of course, graph-based search, understanding sort of related terms and understanding how documents interrelate, very similar to how Google has done it. We've seen many enterprises do that within their own organizations using Neo4j. So the companies that we talked about, not only do they exist in many different verticals, but these companies are using Neo4j for a lot of the use cases that I just talked about, and finding it very successful within their organizations. And oftentimes when one of these companies adopts, they adopt it for a single use case to start with, but then it really expands throughout their organization. So I actually am friends with a VP at one of our larger customers, and I know that his organization already uses Neo4j, but he actually reached out to me last week and said, hey, can we talk? Like, I see you joined Neo4j. Can we talk about how we can use it within our part of the organization? So this happens every single day, and people are finding success across an initial use case and then expanding it throughout the rest of their company. So here's a few quotes from the analysts. For those of you that like to look at what the analysts are saying, the Gartner quote here is perhaps the most powerful. The single most effective competitive differentiator for organizations pursuing data-driven opportunities is a graph database. And then Forrester estimates that over 25% of enterprises will be using graph databases within the next 2 years. So there's a lot of energy around graph databases. People are understanding where they fit within their organizations and then expanding the usage. So in order to take advantage of graph databases, you need to model your data as a graph, and then really use that relationship in real time to transform your business. Graph databases are meant for, and especially for Neo4j, are meant for this online transaction processing. Make it your key data store for your business data when relationships are key. And that's really the power of graph databases is high performance type queries. It's not an analytics solution. Some people use it for analytics, back-end analytics and that sort of thing, but it's really meant for your online processing of data in order to deliver real-time results to your employees and customers. And you can add new data and relationships on the fly as the business changes, and it's super easy to do that without restructuring your database. Ironically, relational databases don't actually handle relationships well. You all have probably had some experience either as a customer of an IT group that is using a relational databases, or as that IT group, or as that developer that's building on a relational database. And you've noticed that relational databases do have challenges. They're not suited to really model data as a network of relationships. You put data in rows and columns, and you have to figure out how those rows and columns relate to each other. And to do that, you do joins. But performance degrades a lot with the number and levels of relationships, as you require a large number of joins to normalize table, or even many self-joins in some types of queries. The performance really vastly degrades. And then you try to figure out how to improve that performance by accessing less tables or by denormalizing your data, and then it becomes just a lot harder to maintain your database. And so this all makes it really hard to use for real-time applications where the data model is changing and where the data itself is constantly changing, and you're trying to get a high level of performance on your queries. And then, NoSQL databases don't handle relationships. And I will preface this with saying that many people include Neo4j and graph databases in the NoSQL space. And so in this case, we're referring to NoSQL databases that aren't graph databases. They don't really think about relationships. They are, teaching people to denormalize their data in order to get the best performance. And in the process of denormalizing your data, you create copies of your data that are hard to maintain. And there's really not these, query constructs to support data relationships. If you want to handle data relationships, typically you have to do that at sort of create time, at write time, when you put your data into one of these NoSQL databases. And then you need to, if you don't do it at write time, then you need to put that logic within your application. And they also don't have ACID support for transactions. That's one of the key things that we found to be really important for our customers and use cases is ACID support. If a bank is dealing with Neo4j for their master data, or a company is dealing with Neo4j for their identity and access management, as well as the organizational chart, they need to make sure that as soon as a transaction is written or is committed, that it is written to disk and it will be available in the future. And sure, there are some types of use cases where you don't need ACID support, but the vast majority of the use cases that we see do greatly benefit and or require that ACID compliance, and Neo4j provides that, unlike many of the NoSQL databases. So let's talk about imagining your data as a graph. So the idea is like you model your data into these nodes and relationships, and you're able to query that in real time. And like I said earlier, the whiteboard model is the physical model. Key product features of Neo4j. We've mentioned a lot of these throughout the beginning of the presentation, but let me just reiterate a few of them. So ACID compliance is critical. Integration with a lot of different popular APIs and integration with a lot of different programming languages and tools is also very important. So Neo4j did spin off its roots as a Java application. That's how Neo4j was originally developed. It was built for Java developers. But it has grown up a lot since then. Neo4j is now used by our customers and the large community of Neo4j users by from many different programming languages. So Neo4j provides a REST and RPC layer that you can access Neo4j from any language that you want. And we consider that really important because people have their language choices and their expertise for various reasons. And we want you to be able to access Neo4j from anywhere. So it's no longer just Java as much as the J remains in the name Neo4j. You can really integrate Neo4j with your systems that are running in any different programming language. And we provide drivers, and our community provides drivers for many of those. But if you're using some obscure language, as long as it supports HTTP, you can access Neo4j and both put data in as well as run queries. We support scalability, vertical and horizontal scaling that is optimized for graphs and getting you accurate and timely results from graphs. And it's really all about the speed, the performance, the millions of hops per second in real time. So let's talk about the components of a graph. I briefly mentioned this earlier as in terms of how we model data into a graph. So we have these nodes. The nodes represent the objects. And then we have the relationships between the objects. So if you thought about the fraud model earlier, the nodes were things like an address or a person or a social security number or a telephone number or a bank account or a credit card. In this case, we're talking about a person and a car. And the nodes can be labeled. That's what the person is or the car is. And they can have properties on them. So here are the various properties on a person. So we have a label on the person, which is person. And then this particular person at the top left here is named Dan. That's one of the properties. And his birth date is another property, and his Twitter handle is a third. And then you have the relationships. So in this case, Dan loves Anne. And luckily, as life would have it, Anne also loves Dan. Luckily, that's not a one-way relationship here. But loves is the relationship, and those relationships can actually have properties as well. And we can see here that Dan also lives with Anne. So you can have multiple relationships between the same nodes. And in this case, Anne owns the car, and Dan drives it. Don't know if, this graph doesn't say that Anne drives the car. Maybe she just owns it and lets Dan drive her around. But the properties also exist on this relationship. You can see, so Dan started driving the car on January 10th, 2011. I guess their relationship got far along enough that Anne trusted Dan to drive her car. And then, you also have the properties on a car, which are the, Volvo and V70. So as we think about taking a relational model and converting it into a graph model, it's actually, a fairly simple operation because of that idea that the whiteboard model is the physical model. So the way you think about a relational model here, is you would typically have a person, and then you would have a friend, and then you would have a mapping between people and friend, or you would have kind of a self-mapping to the same table. And that's how the relational model would look. And the graph model is just, the person knows this other friend. And so Andreas knows Tobias, Andreas knows Micah, Andreas knows Delia. And it's a very simple model that's easy to understand. So there's a query language which we call Cypher. I mentioned that Neo4j is accessed from any different programming language using a REST and RPC API. The query language that's used to access it is called Cypher, and it's a very similar query language if you're already familiar with SQL, but it's really optimized for dealing with data relationships. So in this case here, we have Dan loving Anne, and if we had a very simple query to match this existing relationship, which we already know, we could say match the node where the person node where their name is Dan, who loves the node with a person whose name is Anne. We already know, obviously, as we formulate that query, exactly what the result is going to be, as long as that node or those two nodes in that relationship exists in the graph. So we'll show you a little bit more interesting queries here going forward. So let me drop into a copy of Neo4j where I'm going to show you a different data set. And I'm going to show you the Northwind data set here. And let me see. I'm going to actually just come out of the slides and show it to you in the terminal, but I will try to make things a little bit larger. And I'm going to kind of start over here. And hopefully everyone can see my shell a little bit better here now that I've increased the size. So we have this Northwind data. And I'm going to start loading that data, and it's loading from an external repository. I'm going to start loading that data. I'll jump back into the slides then for just a moment and talk a little bit more about that data while the data loads. It's pretty quick, but it is loading it from an external server. So again, I'll try to keep the size here large. Okay, so that data is loading. Let me hop back into the presentation here and talk about the Northwind data set. And so the Northwind data set is customers, suppliers, and product data. So this is what oftentimes is referred to as master data. And let's think about the model for that. The model for that is, an employee sells an order. The order is a product within the product catalog, and that product is part of a particular category, and that product is supplied by a particular supplier. This is what the data would typically look like in a relational database. This is the requisite Northwind example. But the requisite Northwind example, for those of you who are familiar with the history of this, the Northwind example actually came out of SQL Server. This is an example of using a relational database. But oddly, it's actually an example that shows us the power of a graph database. This example has been around for many years, but it shows it's all about the relationship between all of those tables that we saw in the ER diagram. And the relationship is very important here. So it is really essential to map it in a way that both the business owners as well as the IT and tech folks can understand. And that makes it a lot better to map it as a graph than as a relational database. So how are we going to build this relational database model? Oh, sorry, how are we going to build the graph model from this relational database model? Well, it's simple nodes and relationships like we talked about before. So first of all, in our relational model in this ER diagram, we notice and locate the foreign keys that are used to relate data between different tables. And the foreign keys become relationships. So you can see here we got rid of the order ID and the order details and just have it items in a particular order. We got rid of the category ID and supplier ID in our products table, and we just have a supplier supplying that product. And then we drop out the foreign keys, making this a little bit easier. This allows us to kind of remove some of the complexity of the model. We find our join tables, and in this case, the order details table joins between orders and the products. And the join tables also become relationships themselves. And if then there's attributes on the join tables, then those become properties in the relationship. So you can see here a order includes products, and as part of the include relationship, there's several properties including the price and quantity and any discount applied. So we're going to work with a subset of this data today with our Northwind graph model. And so this is the data we're looking at. We're looking at products, suppliers, categories, orders, and then the employees that sold those orders. And this is what the model ends up looking like. An employee sold an order. That order contains products, and there's a supplier that supplies those products, and those products are part of a particular category. So queries. Who do people report to? So in the case here, Stephen reports to Andrew. And you can do a simple query like we did earlier with the love statement to see that relationship where we have labels and properties defined in our query. So we're finding all the nodes labeled as employees with a property with the first name Stephen, who report to nodes with the label employee with a property of first name Andrew. So very simple query here. I'm going to jump over now back into Neo4j and work on showing you that query. We actually have a document that contains all of these queries and contains the load commands that you can use. I'll make sure it actually loaded. Yep, looks like it loaded. Contains the load commands that you can use through Cypher in order to populate the data set in your own instance of Neo4j. And you can see here now I have categories, customers, employees instead of the fraud data from earlier. So here we can execute this query, and we can find all the employees and what their reporting relationship is. And you can see already, just by having this as a graph model versus a relationship model, it's actually pretty easy to see that Andrew has both direct reports, Janet and Margaret and Nancy and Laura, as well as indirect reports, Robert, Ann, and Michael. And there's another manager that reports to Andrew named Stephen. It's really easy to see that in a graph model, much more difficult if you were to try to see that in a relational model. And let's see here. I don't know if you're going to still be able to see that when I maximize it like that. So let me maximize it over here. But so that's a very simple query. And now let's get to something that's more interesting and shows the power of graphs. So let's say we want to see all of the employees or the employees that Robert reports up through. So we can see here, we're querying based off of Robert, and we can see Robert reports up to Stephen, and Andrew is Stephen's boss, and that's the end of the reporting chain. It's a very, very simple query you can do in Cypher that obviously would be much more difficult for those of you that are experienced with SQL to do in a standard SQL query. Now here's a fun one. Who is the big boss? Look through the entire graph and figure out the person who is an employee that does not report to anyone or reports sort of to the empty set. And we'll call that person the big boss. And we know earlier from looking at the graph that that big boss is Andrew. But again, this is a really interesting query to do that makes a lot of sense in a graph database. But now let's do something that may be more revenue generating for those people in that side of the business. So we want to figure out product cross-selling. So we want to figure out, in this case, what products are sold along with chocolate by what employees and at what quantity. And it's a pretty simple query here. We have the product node that we're looking for and the relationship of product. And the other node we're looking for is an order. And we're looking for that order having been sold by an employee. And let's just run that here. And we can see that the employee named Margaret sold, and I'm not going to pronounce this, sold this other product, we'll call it Gnocchi, 14 times along with chocolate. And Janet sold the Gumbar, and again, not going to try to pronounce that, 12 times along with chocolate. And this is a really sort of powerful query that you can see what employees are selling what items along with what other items. So especially if you have a challenge to get your employees to cross-sell particular products that are sort of accessories to other products or are add-ons, maybe support add-on along with a software product, for instance, you can see which employees are doing that and at what quantity. So those are a couple of the really interesting graph queries that you can do with this Northwind data. And again, we'll share that Northwind data out for all of you so you have access to that. And we just have this public doc that we'll share out to you with the way to load the data in, as well as some of the queries that you can run to explore it. And I'm going to hop through these queries here because we've already shown this, but this is one thing that may resonate with the developers out there. The find all direct reports and how many people they manage up to 3 levels down is a very simple Cypher query. Whereas the SQL query here, this actually came from a real customer use case. They had written this SQL query. They had hand-coded this SQL query, and that's obviously many more lines than the Cypher query. That's really why we, one of the main reasons we created a graph database and created Neo4j is just to make lives easier for developers as well as business owners. Nowadays, business owners really expect developers to be able to respond to a text message to answer a query. They don't have a week to produce a report or something like that. They're supposed to, answer the business questions super quickly, and the Cypher query language and graph databases really enable answering those business questions quite quickly. So I just did want to include at least one customer quote here and customer example. eBay has been using Neo4j, and they found it to be literally thousands of times faster than our previous MySQL solution. So not only is it easier to develop the applications, but the performance is so much faster. And they've also proven here that the ease of developing application with 10 to 100 times less code than their previous solution. So you can imagine how that makes it easier to maintain their applications in addition to providing faster response time for their users and customers. All right, well, that really reaches the end of the presentation here. We've talked about Neo4j and how Neo4j is the world's leading graph databases with customers across many different verticals using many different use cases, from graph-based search to fraud detection to master data management and others. We've also shown you the Cypher query language and talked about how Neo4j can be accessed using a REST and RPC API with that Cypher query language, which is very simple and easy to use, and very especially easy to learn for those folks that already understand SQL, but takes advantage of the graph database relationships. And we've talked about in general what type of performance you should be able to get out of graph databases, what the value is of using graph databases to store your data and query your data, and how Neo4j, is really meant for that online transaction processing. You have the ACID compliance, and then you have, the Enterprise Edition has all the security and performance requirements necessary to build large-scale applications on within the enterprise. So now I'm going to open it up if there are any questions that I can answer, and I believe Adam will pass those questions on over to me. And Adam, are there any questions that have come in?
Yeah, and before we answer those questions, I just wanted to thank you, Ryan. That was a really great introduction to graph databases and Neo4j, and I'm sure everyone out there listening enjoyed it as well. So we have a bunch of questions coming in, and I encourage everyone to continue submitting questions. You'll see your questions portion of your control panel. So one question that's come up a few times is talking about scalability. And people are kind of wondering if you have any benchmarks or anything you can mention around Neo4j scale.
So we ourselves don't publish any benchmarks. There are benchmarks out there on the web, and honestly, I'd really encourage you to test it against your own applications. As you saw today, I just downloaded Neo4j and got data into Neo4j and started running queries on it in less than a minute. So it's really easy for you to use your own data as a way to test Neo4j and the performance of it. But I do want to say is performance is one of the key reasons we designed your graph database and we designed Neo4j. When those relationships are really important, the ability for us to traverse data from one node to another node through that relationship in our native graph data store is critical and much faster than traversing multiple tables and doing joins, a lot of self joins and all in a relational database. We do scale to many different, many nodes. You can run Neo4j across many nodes, and we automatically handle the replication of the data across those nodes. And when you perform a query, you can perform that query on any of those nodes, and always know that you have up-to-date information, across all the nodes in your cluster in order to perform that query. So the performance is really fantastic for most use cases that we've come upon, and I'd encourage you to test it out yourself, and certainly reach out on Stack Overflow if you have any questions, or you can reach out to our sales team and the technical folks there if you have any questions as well. But yes, performance is one of the key reasons we built Neo4j and one of the key value propositions of a graph database.
Great, thanks, Ryan. And so another question that's come up is from Basim, and he's asking, how easy is it to add new relationships and entities?
Adding new relationships and entities is quite easy. It's basically the same as just loading in additional data. You saw when I switched between the fraud example and the Northwind example, I actually just kind of started up a new instance of Neo4j. But I could have very easily added all my load commands from the Northwind example directly into the same data set. And there would be no modifications necessary whatsoever. It's not like you actually have to do your DML statements to modify your SQL tables. You basically just add the properties, add the nodes, add the relationships, and there's really no kind of advanced work required. That's one of the great benefits of graph databases is you don't really have this predefined schema that you have to conform to. You can just write your statements on the fly and expect that your graph model will adjust to those.
Great, thanks. And then I also have Nawazish asking, what learning resources would you recommend?
Sure. Let me actually see. I do have a slide on that I skipped over in this presentation, but there's a huge community out there. So like any developer is familiar with, Stack Overflow is a great way if you have a question to get an answer, if there's a technical question. But we also offer a variety of other ways to learn about Neo4j. There is a book on graph databases written by a number of folks on our team, including folks like our chief data scientist and our CEO, published by O'Reilly, and you can get a copy of that book for free. Just look around the Neo4j website and you'll find that link. We also do offer training, and that training is offered various places around the world. It's sort of a one-day training class, and you'll see that advertised on neo4j.com/events. And feel free to reach out to us if you're looking for when the upcoming training is in your particular area. And we, offer on-site training if there's a business that, is really interested in Neo4j and wants to get a bunch of their staff trained up. We do on-site training as well for that. So those are a lot of the resources. You can also attend your local meetup group. There are meetup groups in cities all around the world and talk with other developers about how they're using Neo4j, or go to some of the presentations there. There's an online training course. There are the things called GraphGIS, which you saw earlier with the fraud detection examples, so kind of play-by-play tutorials that you can go through. I personally would first start by downloading Neo4j, getting it up and running, and then you can see the sort of step-by-step training that it does with the movie data set, as well as some data in the Northwind data set. And then your next step probably depends on what sort of use case you have and what type of data you have. But there's a lot of different learning resources out there, and if there's anything that you see missing, feel free to reach out to us on our Google group, or ping me on Twitter or anything like that, and we're happy to help.
Great, thanks. And just so that everyone knows, in the chat portion of your control panel, I dropped the links to the Graph Databases book published by O'Reilly Media. Also, neo4j.com/Graph Academy, which is our hub for all things Neo4j training related, and then also the Neo4j community link. So we have time for a few more questions, Ryan. And one that I think you've touched on, but I think would be good to kind of clarify more, comes from Bala, and he's asking, what kind of applications would Neo4j be useful for? And then, similarly, some people are asking about, what are the differences between RDBMS and graph applications?
Sure. I mean, I think that, Neo4j as an OLTP database. Sorry, those acronyms are getting to me. But Neo4j deals with online transaction processing very well, just like any other database that deals with online transaction processing and has ACID compliance. So, really the choices of types of applications that you can build on top of Neo4j is infinite. Any type of application which requires a backend data store can be built on Neo4j. But there are certain types of applications which we see over and over again built on Neo4j, types of applications that the data relationships are really important for. And that, the real-time recommendations, fraud detection, master data management, network and IT operations, identity and access management, and graph-based search. We've seen these time and time again. We have case studies published online about how companies are using Neo4j for these types of applications. But really anything, right? You can store any type of data in Neo4j. The data that's going to be most meaningful in a graph database is data where the relationships are critical, not just sort of kind of log data or things like that, but data where the relationships are highly important to your business, which is frankly most types of data. So it's really a database that can be used universally, but we find the most value in these use cases here. And in terms of data or types of problems that you'd want to do in a graph database versus a relational database, I mean, I may be biased here, but I really think the default type of database that customers should use is a graph database, though I recognize that there's 20, 30, whatever, maybe even longer years worth of expertise out there in in relational databases and in SQL. So we do find a lot of our customers using Neo4j in what's called a polyglot environment. So we find them using Neo4j along with their other databases. So in this case here, we have our application that's accessing both our relational database as well as our NoSQL databases and Hadoop clusters, but it's also accessing the graph database cluster. And we provide, we find people that are doing this environment where all of the data exists inside Neo4j for a particular type of application, or where there's actually a hybrid model. So there's several different ways to load your data and use your data in Neo4j. You can migrate all your data. Certainly, this is something that many companies do for applications, is migrate all their data, and they see the value in using relational databases. In using graph databases for their data problems. But we find people that also just decide to migrate what looks like graph data to them, and they keep their non-graph data in a relational database. So they keep their sort of like log type data or event type data in the relational database, and then in the graph database they keep the data where the relationships are the most important. And then some folks really just take all of their data and duplicate it. They keep it in their relational database as well as keep it in the graph database, and they're able to perform both types of queries. So we're seeing all these different scenarios of what we call polyglot persistence of data. We encourage you to do what's right for your organization. Obviously, we believe that graph databases is where it's at today and where it's going to be at in the future, and that relationships are really, really important. And it's important to be able to query these relationships quickly. And Neo4j and graph databases provide that. But we understand that you need to fit in with your existing enterprise architecture, and find ways to integrate with your other NoSQL databases or your relational databases, and Neo4j supports that, and we have many customers doing that. And one of the other slides that I'm just seeing that I didn't show here yet is people are really finding Neo4j as solving their problems, and they're super excited about it. Here you see some of the top influencers. John Resig at the top left is the creator of jQuery, which is a very popular JavaScript framework. I think one of the other key technologies that he likes besides JavaScript is clearly Neo4j. And he says what used to be a bunch of complicated analysis scripts are now a handful of simple Cypher queries. So try putting your data into Neo4j, even if it's in a test or dev environment. See what it looks like to query and run your analyses on Neo4j. See what it's like then to start moving your actual transactions and live data over to Neo4j, and take the steps that you're comfortable with. But we do believe Neo4j can be useful for most types of applications, and definitely all types of businesses.
Awesome. Thank you, Ryan. Really appreciate your detailed answers to those questions. And I apologize to all those out there with other questions that we don't have time to answer. But if you do have any more questions, feel free to reply to webinar@neotechnology.com, or you can reach out to Ryan on email or Twitter as well. Just a few housekeeping things before we go. I'll be sending out an email tomorrow with a link to the slides and a link to the recorded video. So you'll have those in your inbox tomorrow morning. And like I said, feel free to email us with any questions. Thank you again for joining us, and thank you, Ryan, for presenting.
Thank you, everyone.